So let us continue with the nomenclature of alkenes. Nomenclature of alkenes. Nomenclature of alkenes. In the 10th standard, you have studied what are alkenes. Let us first define alkenes. Alkenes are open chain. They are open chain. Aliphatic. They are open chain. They are open chain. Unsaturated hydrocarbons. Unsaturated hydrocarbons. So they are hydrocarbons. Then unsaturation may be due to a double bond or a triple bond. It may be due to a double bond or a triple bond. Here the unsaturation is due to a double bond. So we can add that also. So open chain unsaturated hydrocarbons with a carbon-carbon double bond. There is a carbon-carbon double bond. And there will be a general formula for alkenes. Do you remember the general formula? CnH2n. CnH2n. That is the general formula for alkenes. Where N is the number of the carbon atoms. N is the number of the carbon atoms. So the minimum number of carbon atoms in alkenes must be 2. Minimum number, because there is carbon-carbon double bond. There is a carbon-carbon double bond. So the minimum number of carbon atoms, that is equal to 2. And we have seen some examples also. Ethane, then C2H4 ethane, C3H6 propane, C4H8 butane, C5H10, benzene, etc. So the names of the alkenes end with ENE. You take the longest carbon chain containing the double bond. And you take the name of the corresponding alkane. And from the name of the alkane, the ending ANE is replaced by ENE. The ending ANE is replaced by ENE. So that you will get the name of the alkane. And the locants, the number of the double bond, that is also to be mentioned. If there is alkene, there is double bond between the carbon atoms, the double bond should get the minimum locant. And the side chains also. So even if there is side chain, your first preference give to the double bond. Double bond is given the first priority that we have seen. Now let us go to the nomenclature. This you have already seen. Now let us go to the nomenclature of alkynes. Another set of hydrocarbons. So nomenclature of alkynes. Nomenclature of alkynes. Alkynes, they can form a homologous series, and we studied that in the 10th standard also. What are alkynes? So alkynes are, again, open chain, so aliphatic, open chain, unsaturated hydrocarbons. Unsaturated with a carbon-carbon triple bond. There is a carbon-carbon triple bond. And there is a general formula also, and the general formula is CnH2n minus 2. CnH2n minus 2. So we can define alkynes like this. Alkynes are open chain, unsaturated hydrocarbons with a carbon-carbon triple bond. And the general formula CnH2n minus 2, where N is the number of the carbon atoms. I repeat, alkynes are open chain aliphatic, open chain unsaturated hydrocarbons, carbon-carbon triple bond, and the general formula CnH2n minus 2, where N is the number of the carbon atoms. As in the case of the alkenes, here also the minimum number of carbon atoms must be 2, because there is carbon-carbon triple bond. There is a carbon-carbon triple bond. So there should be minimum 2 carbon atoms among the alkynes. And how to name these compounds, alkynes? The names of the alkynes always end with YNE. YNE. The names end with YNE. Alkyne. So the names end with YNE. So all the other rules regarding the nomenclature of the alkanes are holding good here also. And to that we can add 2 more points to get the name. You take the longest carbon chain. You take the longest carbon chain. The longest carbon chain containing the triple bond. Containing the triple bond, carbon-carbon triple bond. Longest carbon chain containing the carbon-carbon triple bond. Then, what you do? You take the name of the corresponding alkane, and from the name of the corresponding alkane, the ending ANE is replaced by YNE. That is replaced by YNE. That is the rule. Forget the name. You take the longest carbon chain containing carbon-carbon triple bond, and you try to name that parent hydrocarbon chain. And to name that parent hydrocarbon chain, what do you do? You take the name of the corresponding alkane, and from everything in the IUPAC system of nomenclature, for everything the basis taken is alkane. For everything the basis is alkane. We start from alkane. Alkane. That is the basis for the nomenclature according to the IUPAC system of naming. So here you find out the longest carbon chain containing carbon-carbon triple bond, and you give the name of the corresponding alkane. From the name of the corresponding alkane, the ending ANE is replaced by YNE to get the name of the alkyl. Then there is triple bond, and we have to mention the position of the triple bond. Mention the position of the triple bond as before. The triple bond should get the lowest locant. The lowest, the smallest number, the lowest number is given to the carbon-carbon triple bond. That is given the lowest number. And then the possible lowest number to the side chains also. The triple bond should get to the lowest locant. The side chains also should get to the lowest locant. But you give priority, you give preference to the triple bond. You give preference to priority to the triple bond. Only after that you consider the next lowest number for the side chain. Okay. So let us take some examples for this. Say examples. Say C2H2. That is the simplest compound possible. C2H2. Among alkynes, The lowest compound is C2H2. And if we draw the structure is CH, triple bond CH. That is the structure. Okay. And how to name this compound? You take the name of the alkane with the two carbon atoms. The name of the alkane with the two carbon atoms. Do you remember? It is a ethane. Ethane. That is the name of the alkane with the two carbon atoms. Now we have to do, we have to replace the ending ANE, by YNE. So we get the name as a ethane, and that is the simplest compound. The smallest compound is ethane, CH, triple bond CH, ethane. Here there is no need for giving the position of the double bond, because there are only two carbon atoms, not a double bond or triple bond, because there are only two carbon atoms. Now let's take the next one. So it forms a homology series. So how to get the next higher one? How to get the next higher one? Vidur. How to get the next higher one? The next higher homologue. How do you get it? Say Aditya. Aditya.
Sir, by general formula.
Pardon?
Sir, general formula.
Gender formula. Gender formula is
C3H4.
it's a very simple thing. I told you that the alkanes can form a homologue series. So the difference in molecular formulae of a two successive members is only CH2. CH2. So to get the next higher number, what you have to do? You can use the gender formula, that is right. The easiest way is this. You add a CH2 to this. You add a CH2 to this. So that this will become C3, H2. Add C3, H4. Okay. The same thing is obtained from the gender formula as you told. As you told, the same formula can be obtained. And how to draw the structure? Say a chain of 3 carbon atoms. So it is CH3, C triple bond CH. CH3, C triple bond CH. And that's the structure of C3H4. And how to write the name of this compound? You take the name of the corresponding alkane with the 3 carbon atoms. The alkane with the 3 carbon atoms, it is a propane. It is a propane. From that, you replace ANE. You replace ANE by YNE. So the compound is propine. C3H4 propine. Then the next higher one. What is the easiest way to get the next higher homologue? Riya, how to get the next higher homologue?
Plus CH2.
CH2. You add a CH2 to this, so that C3, H, complete.
C4H6.
Yeah, CH2. So it is a H6. H6. So not a sorry. It is not a C3, it is a C4. C4, H6. You have added CH2. And how to draw the structure? The structure will be, say, a chain of 3 carbon atoms. A chain of 3 carbon atoms like this. Then there will be triple bond. Triple bond between the carbon atoms. The triple bond between the carbon atoms may be between the first and the second carbon. Or the triple bond may be between the second and the third carbon atoms like this. There is a position isomerism. Okay. So there is a triple bond between the first and the second carbon. Similarly, a triple bond between second and the third carbon also. Okay. So these are the two basic skeletons for a chain of 4 carbon atoms. There can be a chain of 3 carbon atoms also. So that the fourth one will be, just wait. The fourth one will be a side chain like this. Suppose, just wait. Suppose, you should not know this. We are thinking of the different possibilities. If it is so, then we have a propine with this carbon skeleton. Can we have a propine with this carbon skeleton? In a propine, there should be a carbon-carbon triple bond. Triple bond. Just wait. So you think of the middle carbon. Say in the middle carbon, now how many covalent bonds are there? There are 5 covalent bonds. 5 covalent bonds. So such a structure is not possible. Such a structure is not possible. So the only 2 possibilities are given as it is given here. A chain of 4 carbon atoms. But the positions of the triple bonds are different. Now you try to complete the structure. You take carbon atom number 1, the left extreme, carbon atom at the left extreme you take. So only 3 covalent bonds are already there. So there is a provision for 1 more covalent bond, and to that you can add a hydrogen atom, so that it is CH. Now you think of the next carbon. How many hydrogen atoms will be there? Aditya?
Sir, no hydrogen atoms.
No hydrogen atom, because valency of carbon that is equal to 4. All the 4 valencies are already utilized. That is already utilized. And there is no provision for hydrogen. Now you come to the next carbon. The next carbon, 2 bonds are formed. So 2 more valencies are there. And you can add 2 more hydrogen atoms, CH2. And you come to the last one. Only 1 bond is formed. So there is provision for 3 more covalent bonds. And to that you can add 3 hydrogen atoms. So that is the structure. You complete the structure. Now you count the number of the hydrogen atoms. Is it tallying with the given formula? Is it in agreement with the given formula? You say yes or no? Is it yes? C4H6. Is it correct? Yes.
Yes, sir.
So the second structure. Here it is CH3. And what about the second carbon? There is no hydrogen. Third carbon, there is no hydrogen. And the last carbon, there is CH3. So these are the 2 possible structures of with the alkynes with the C4H6. And how to name this compound? You take the name of the corresponding alkane with 4 carbon atoms, butane. From that ane is replaced by yne. So it is butane. Okay, it is a butane. Right? Butane. But there are 2 butanes. We are seeing 2 butanes are here. Both are isomers. Both are position isomers. Position in the sense, the positions of the triple bonds are different. So, in the first compound, just a number the carbon atoms. When you number the carbon atoms, the carbon atoms bonded by the triple bond should get the least locant, the least number. So that the numbering is like this. Say 1, 2, 3, 4. That is the correct way of numbering. And if it is so, the triple bond begins from the first carbon, and therefore the compound is bute 1-ine. It is butane 1, or 1-butane, or bute 1-ine. If it is so, what about the second compound? The second compound, the triple bond begins from the second carbon. The triple bond begins from the second carbon. and therefore it is a butyl. It is a butyl. Butyl, that is also a correct naming. 2-butyl or butyl 2 or butyl. Butyl. Okay, so there are 2-butyls, and both these are the position isomers. Okay, let us take one more example, and that is the pentyne series. 5 carbon atoms. 5 carbon atoms. So C5 add CH2, H8. C5 H8. I just think of the various possible structures for this compound. This is our pentyne. This is pentyne, which are the possible isomers. So pentyne. You can think of a carbon chain of 5 carbon atoms, a straight chain of 5 carbon atoms like this. A straight chain of 5 carbon atoms. Another one, a straight chain of 4 carbon atoms. And the fifth one is a side chain, say like this. Fifth one is a side chain. So you can think of it like this also. Okay. Now, you think of the carbon-carbon triple bonds. Carbon-carbon triple bonds. You start from the first chain, a straight chain of 4 carbon atoms. Here, the triple bond that begins from the first carbon. Now you can change the position of the triple bond. That is from the second carbon. So it is C, again a chain of 5 carbon atoms. And here there is a triple bond. And it begins from the second carbon. If you change the position again to the right hand side, what happens? That's only a repetition of this one. This one. Because in that case, we have to start numbering from the right hand side. So that the triple bond gets the lowest. Triple bond gets the lowest locant. So these are the only two possibilities. Only two possibilities in which the positions of the triple bonds are different. Now try to complete the structure. You take the first carbon, you start from the first skeleton. You start from the first skeleton. And here, on the first carbon, there is one hydrogen CH. CH. You go to the second carbon, there is no provision. Because all the 4 valencies are already satisfied. You come to the third one. Here CH2, here also CH2, and here CH3. Now the structure is completed. And what about the number of the hydrogen atoms? 3 plus 2, 5 plus 2, 7 plus 1, 8. Okay. Now you come to the second skeleton. In the second skeleton, CH3, second carbon, there is no hydrogen. Third carbon, there is no hydrogen. And the fourth carbon, there is a CH2. And here there is a CH3. Now you come to the third skeleton. You think of the positions of the triple bond. Where will be the triple bond? Where will be the triple bond? You just think of it. You try to draw the triple bond between the carbon atoms. Where can you draw the triple bond? You draw yourself, you try. You try yourself. So, where will be the position of the triple bond? You say the position of the triple bond. Okay, I shall mark this as 1, 2, 3, 4. Okay. Now you say, where will be the position of the triple bond? Achyut. Between which carbon atoms? The triple bond.
1, sir. 1 and 2. 1.
1 and 2. 1 and 2. Because in all the other carbon atoms, there is no provision. If you draw a triple bond, it will exceed the valency 4. Is it not? It will exceed the valency 4. So the position of the triple bond will be here itself. It is here. It is between the first and the second carbon atom like this. Complete the structure. And this is a CH3. What about the third carbon? It is a CH. Here CH3. Here CH. The structure is completed. And how to name these compounds. Okay. Let us take the name of the first compound. There's a chain of 5 carbon atoms. The corresponding alkane is pentane. Pentane. Now ANE is replaced by YNE. So this is pentyne. Pentyne. The triple bond begins from the first carbon. The triple bond. Say numbering like this. 3, 4, 5. The triple bond begins from the first carbon. And so the compound is say pent 1 ine. Pent 1 ine. Pent 1 ine. Or 1 pentyne. 1 pentyne. Or pentyne 1. Pentyne 1. Or a pent 1 ine. If it is so, what will be the IUPAC of the second compound? That is also a pentyne, and the double bond begins from a triple bond begins from the second carbon. Say 1, 2, 3, 4, 5. The triple bond begins from the second carbon, and so this is pent 2 I, pent 2 I, YNE, pent 2 I. Okay. Now you come to the third compound. In the third compound, there is a branching. There is a branching. There is a methyl group. CH3 group is called a methyl group. CH3 group is a methyl group. So if there is branching, then what you have to do? You have to take the longest carbon chain. You have to take the longest carbon chain. So this is the longest carbon chain. Carbon chain contains 4 carbon atoms, the longest carbon chain. And we give the name, derive the name from the longest carbon chain. There are 4 carbon atoms, so it is a butane, butane, a derivative of a butane. And triple bond begins from the first carbon, and so it is a but1ine. And there is a methyl group, and that's on the third carbon, and so it is a 3-methyl. The compound is 3-methyl, 3-methyl, then 1, 2, 3, 4, but1ine, but1ine. There is no meaning in saying but1ine in this case, because there can be only but1ine. There cannot be but2ine in this case, in this case. Okay. And now let us follow the IUPAC rule strictly. Everywhere we are following the rule. IUPAC has got its own rules, just like our school has its own rules. We can follow the same rule. It is just like a post call. Post is the same as the call, the pillar. Okay, so we can follow that rule here also. Otherwise, the examiners who are following this, they will not be giving the full credit. Because there will be very intellectuals. So you just follow this rule. So you can write it 3-methyl but1ine. Okay. So 2-methyl but1ine. And that is the way of naming the alkynes. Triple bond compounds, alkynes. Let us take some special cases. Some special cases. Some special cases. That is, suppose there is a double bond and a triple bond. Double bond and a triple bond in a compound. Double bond and a triple bond in a compound. Okay, let me take an example. Say CH, triple bond C, CH2, CH2, then CH, double bond CH2. See, there are double bond and triple bond. There is a double bond, that is ene. Double bond, ene, alkene, alkene, ene. If there is a triple bond, it is ine, alkyne. So this is ene, ine, ene, ine, ene, ine. See? Ene, ine. It is not the ine, ene. It is a ene, it is a ene plus ine, and not ine plus ene. You must follow the alphabetic order. Follow the alphabetic order. In the alphabetic order, ene comes first and ine. So that is the correct way. So combine these two, then the compound will be ene, ine, ene, ine, ene, ine. There is a space between these two, ene, ine. Okay, let us try to give the name of this compound. Say, how many carbon atoms are there? Say, number of the carbon atoms. You count. Regarding the numbering. Okay, so 1, 2, 3, 4, 5, 6. Say numbering like this. If say I number it is like this. Say 1, 2, 3, 4, 5, and 6. Now the positions of the double bond and the triple bond will be different. And which is the correct way of numbering? Correct way. From right to left, the double bond begins from first carbon. From left to right, the triple bond begins from the first carbon. And which is the correct way of numbering? We have to follow the alphabetic order. That is one thing. Secondly, we have to follow the priority rule. In the priority rule, ENE has more priority than YNE. You just remember the alphabetic order. In that alphabetic order, there will be the priority rule also. The ENE, that is given higher priority compared to YNE. Just like the alphabetic order. So ENE, it should get to the lowest locant. So that the first way, that is a orange colored numbering from right to left. And that is the correct way of, say, numbering the carbon atoms in this compound. Okay. Now, let us try to name this compound. You take the name of the corresponding alkane. There are 6 carbon atoms. So it is hexane. Hexane. From that, you replace A and E by ene and ine. Ene and ine. So the compound is hex. Then ene. Ene begins from the first carbon. So 1 ene. There is no ending E. If there are two, so if there are two function groups like this, the ending E of the first one is discarded. So X1 ene, then you write the ine. The ine triple bond that begins from the fifth carbon, and so the compound is 5 ine. See? X1 ene, 5 ine. Alphabetic order. We follow alphabetic order. X1 ene, 5 ine, and that is the IUPAC name of the compound containing double bond as well as triple bond. You give priority to ENE, and only after that YNE. You need not bother about it much because you just follow the alphabetic order E and Y. So E comes first, and that is given the lowest locant. Okay, that is a special case 1. Now you take another one, second. Suppose there is a cyclic compound. In the cyclic compounds, you just prefix you prefix the word cyclo. Cyclo. Cyclo is a prefixed. Prefixed. So you prefix the word cyclo, and the rest you can write as such. The rest as such. That is ANE, ENE, or YNE, whatever it is. But you have to write cyclo first. Prefix cyclo. Cyclic compounds. Okay. Let us take some examples for this. Say, for example, a compound like this. Do you remember this compound? This compound. Okay. The compound is CH2, 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 CH2. That is the compound. There are 6 carbon atoms. 6 carbon atoms. And all are single bonds. Single bonds. So it is a cyclic alkane. Cyclic alkane. So alkane with 6 carbons. Alkane with 6 carbon. Only single bonds are there between the carbon atoms. And so say alkane with 6 carbons. That is named as hexane. That is a hexane. Hexane. What is a cyclic compound? So you prefix cyclo. Cyclo. So the compound is cyclohexane. Cyclohexane. So cyclic compound, there are only carbon-carbon single bonds. Saturated compounds. So you follow the name of the alkane, ANE. So it is cyclohexane. Okay. Cyclohexane. So let us continue. So cyclohexane. Let us take one more example. That is say compound. Say like this. Again a cyclic compound, and here is a double bond. So double bond. And how to name this compound? You must know the structure. This is the bond line structure. Am I right? Am I right? The bond line structure. In the bond line structure, the carbon atoms and the hydrogen atoms are not shown. Is it not? In the bond line structure, the carbon atoms and the hydrogen atoms are not shown. They are hidden. And therefore, this is a cyclic. There is a double bond. So it is alkene. Cyclic alkene. Cyclic alkene. So the compound is CH2. See? And here CH. Double bond CH. Here CH2. Then CH2. Then CH2. See like this. That is the compound. Again, there are 6 carbon atoms. So, an alkene containing 6 carbons, hexene. It is a hexene, ENE, hexene, and it's a cyclic compound. So you prefix cyclo, so the compound is a cyclohexene. Compound is a cyclohexene. Okay. Let us take one more example. After that, we can stop. Third one. Say a compound, say like this. Here there is say a double bond, and here there is say there are 2 methyl groups. The structure is say here CH, CH2, 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 double bond CH. See like this. CH3, CH3. That's the compound. All right? Okay. So, what is the name of this compound? Suppose there are no side chains. There are no side chains. So, it is a cycloalkene. It's a cycloalkene. There are 6 carbon atoms in the ring. So, it is cyclohexene. It is a cyclohexene. Okay, cyclohexene. In cyclohexene, there are two methyl groups. Two methyl groups. So the compound is dimethyl. Dimethyl cyclohexene. Cyclohexene. The methyl group, dimethyl. Since there are side chains, we have to give the locants, the positions of the side chains. The positions of the side chains. So there is double bond as well as there are side chains also. Under such conditions, the more substituted carbon is given the priority. So the priority is given, priority is given to more substituted carbon, that is given the priority. So the first priority goes to this carbon. So 1, 2, 3, 4, 5, 6. Okay. So what will be the position of the methyl groups? That is on the first carbon. The two methyl groups are on the first carbon, and so it is a 1 dimethyl, 1 dimethyl cyclohexene, or a cyclohexene. There is no meaning in that. Okay, you can write it as cyclohexene, cyclohexene. Okay, so the best name 1 dimethyl 1 dimethyl cyclohexene. Here, the position of the double bond should be mentioned because there is another chance also. The double bond may be between third and the fourth carbon atoms. So you have to mention the position. So these are some of the special compounds that you have to see. Next day we can say the aromatic compounds. They are known as the arenes. Aromatic hydrocarbons known as arenes. Let me stop now. Thank you.